Hello and welcome to Nation Innovation. So we are going to start with course of microprocessor and microcontroller. So we will be dealing with microprocessor 8086 in detail. So let's start off. So basically let's see some high level features of 8086. First of all, it is a 16-bit microprocessor. It is a 16-bit microprocessor. That means its ALU internal registers all work with 16-bit binary data. Then it has 20-bit address bus, 20 bit of address bus. That means it can access up to 2 to the power of 20, that is 1 MB of memory location. Next, 8086 has 16-bit of data bus, 16-bit of data bus. That means it can read or write data to a memory or port in either 8-bit or 16-bit at a time. It can support up to 64K input output ports, and its frequency range is the operating frequency range is between 6 to 10 megahertz. One important thing is that these address and data bus, this address and data bus, they are multiplexed. They are multiplexed. What do you mean by multiplexed? Multiplexed means from for the starting 16 bits, they can act as the address bus as well as data bus. Therefore, they are often represented as AD0 to AD15. And after that, from 16 to 19, we have normal address bus. Another important thing is 8086 is decided to operate in two modes. The two operating modes are minimum mode and maximum mode. Minimum mode is basically a single microprocessor configuration, and maximum mode is basically multi microprocessor configuration. And there is a pin called min max, and by applying 1, minimum mode is selected, and by applying 0 on it, maximum mode is selected. Let us now move to the registers of 8086. Basically there are general purpose registers, then index pointers register, segment registers, and two other special registers. Let's start with general purpose registers. So general purpose registers, there are four: AX, BX, CX, and DX. The AX is the accumulator register, that is basically used for input output operations and string manipulations. This AX is accumulator register that is used for input output operations and string manipulation. BX is the base register, and BX register usually contains data pointer used for base-based indexed or register index addressing. CX stands for count registers. So count register, it is used for looping instructions, shifting and rotate instructions. So CX is used for counting purposes. DX represents data register. Data register can be used as a port number in input output operation. And in integer 32-bit multiply and divide instruction, DX register contains higher order word of the resultant, that is of the resultant number. Now all these four types of registers, these four general purpose registers, they are of 16-bit, and each of its register is subdivided into 8-bit each of two registers. For example, AX is divided as AL and AH, lower 8 bits and then higher 8 bits. Similarly, BX is divided as BL and BH, CL and CH, DL and DH, or DX you can say. So this is represented as DL and DH. This DX is 16-bit. Now coming to the index or pointer registers. So these are special purpose registers, and these are also four. One is stack pointer, then base pointer, then source index, then destination index. So stack pointer, it points to the top of the stack. It is basically used to hold the address of the top of the stack. The stack is maintained as a LIFO, last in first out, with its bottom at the start of the stack segment, and that are specified by segment register we will see just now. Then we have BP, which is base pointer. This is also 16-bit register, and it is used to point the data in the stack segment. It is used to point the data in the stack segment. It is usually used by subroutine tasks to locate variables that were passed on the stack by calling program. Then we have source index register. It is used for base indexed and register indexed addressing indexed, base indexed, and register indirect addressing. And this source index is used in conjunction with data segment register to point data location in the data segment. Then we have destination index. Destination index is also 16-bit register, and it is used with conjunction with the extra segment register in string operations, and it is also used in indexed, base indexed, and register indirect addressing, as well as destination data address in string manipulation instructions. Now we are continuously talking about segment registers. So there are four segments: code segment, this is code segment. Then we have BS data segment. Then we have SS stack segment. Then we have ES extra segment. So basically all these are 16 bits. So code segment contains address of 64 KB of segment with processor instructions. Basically it has the area of processor instructions, and this microprocessor uses code segment for all the accesses to instructions referenced by instruction pointer register. So this is basically associated with instruction pointer register. Then we have data segment. Data segment by default, the processor assumes that all data referenced by general registers AX, BX, CX, and DX, all these registers and indexed registers are located in the data segment. So all the data that is represented by AX, BX, CX, DX plus SI and DI, source index and destination index, all these things are initially associated with data segment. Then we have stack segment. Stack segment by default, the processor assumes that all the data referenced by the stack pointer registers and base pointer registers, they are located in the stack segment. They are located in the stack segment. Then we have extra segment. It is used to hold the starting address of extra segment. An extra segment is used to provide for programs that need to access second data segment. Now another important thing is we have two other important registers. First is instruction pointer. Instruction pointer, it is also a 16-bit register, and it is very crucial register because it controls which instruction the CPU executes. Basically, the instruction pointer or program counter, it is used to store the memory location of the next instruction to be executed. It always stores the next address of the next instruction to be executed. Then we have flag register. Now flag register has some status flags and control flags that are basically used to indicate the status of the processor or the results of the arithmetic or logical operations that are being performed. So we will see the flag register in detail. Now let's start with the flag register. Flag register, all the registers which we are discussing right now, right from AX, BX, all the registers are of 16-bit because 8086 is 16-bit microprocessor. So let's start with this flag register. So this is 16-bit from 0, let's say from 0 to 15. So this 0 first bit, it is carry flag. This is C or carry flag. Then first bit is not used. Then second bit, it is used as called as parity. And again third bit is not used. Then we have auxiliary carry, A called as auxiliary carry. Then again after leaving one, we have 0, 0 flag. After 0 flag in continuous, we have sign. After sign, we have T draft flag. Then we have D direction flag. Then we have overflow flag. After that, all the bits are not used. Now let's see. So the direction interrupt, after trap we have one more, that is interrupt flag. So this interrupt, direction and trap, the direction, interrupt and trap, these three are called control. Direction, interrupt and trap, these are called control flags. Direction flag is used in moving data blocks by instructions such as move, compare, etc. And if this direction flag is 0, then it means value up, direction up. and if D equals to 1, it means direction down. Then we have interrupt flag. This flag indicates whether the system interrupts can occur or not, or the system interrupts are activated or not. If I equals to 0, that means disable interrupts. The interrupts will be disabled, and 1 means the interrupts will be enabled. And can be also set by clear interrupt or set interrupt instruction. Then we have trap flag. It means whether or not the CPU is halted after execution of each instruction. Trap means if t equals to 1, that means after executing every step, the programmer can go through his program to debug any errors. And when t equals to 0, that means the trap flag is not active and all the instructions will be executed in one go. Then remaining flags are status flag. So I'll just go through one by one. Overflow. Overflow means that the flag is set when the result of signed arithmetic operation is too large to fit in the destination register. That means if, for example, if you are adding two 16-bit numbers of the same sign and overflow occurs, then this overflow flag will be 1. Then we have carry flag. Carry flag is also generated when the result of unsigned arithmetic operation is too large to fill in the destination register. So this is for unsigned arithmetic operation, and overflow occurs for signed arithmetic operation. This is important. Then we have parity flag is 1. Parity flag is 1 for even parity if the number of ones is even, and for odd it is 0. Then for auxiliary carry, we have auxiliary carry is set when operation causes carry from bit 3 to bit 4. Bit 3 to bit 4, then auxiliary carry flag is set. Then if the resultant of any arithmetic or logic operation is equal to 0, that means the 0 flag will be 1. Sign flag is set when the result of arithmetic operation is negative. That means sign flag is the copy of MSB of the result. If sign bit is 1, that means answer is negative. So that was all for the starting flags. We will continue with the in-depth architecture, and then we will look into programming of 8086.